Hello friends, welcome to my channel. So from today we will see binary search, one example of binary search, and we will also see the algorithm for the binary search. So in data structure, two type of searching technique. First is linear search and second is binary search. So in the previous session we have seen the procedure of linear search. So in that linear search, just we are considering search element and we are comparing search element with each and every element in an array. And here one drawback of linear search is it is time taking process. So if searching element is first position, so the time will be a very short to get output. It will take a less time to get output. Or if the search element is last position of your in array, so the time taking to execution this linear search procedure is more. So that's why linear search is time taking process. So for this purpose we are moving on a binary search. So in this session we will see the binary search. So next we will see binary search. Binary search technique used for a sorted list only, and it is very efficiently and most popular searching technique. It is used to find the location of given element in a list. Binary search is one of the fastest searching algorithm. It works on a principle of divide and conquer technique. So now question is, what is divide and conquer technique? So in divide and conquer approach, the problem is divided into small sub-problem and then each problem is solved independently. So now we will see how binary search work. So consider the following list of element and the element to be searched is 80. So initial first value is a low value and last value is a high value. So here low always less than high because low is your initial position and high is your last position. Now this array is sorted array, so pick any one number. Here we will pick 20. So in 20 left side is always minimum number than 20 and right side is always maximum number than your 20. This is done in any of these number. Here we will pick 55. So in left side is always minimum than 55 and in right side always maximum than 55. So now we will calculate middle value. So middle value formula is lower index plus higher index divided by 2. Here our lower index is 0 and our higher index is 8. So 0 plus 8, it equal to 8. 8 divided by 2, it means 4. So 4 is your index as a middle value. So here 4 is 50. So 50 is your middle value. Now we will compare 80 with 50. Now both are not matched and 80 is lower than 50. Here both are not matched and here 80 is maximum than 50. That means 50 left side is minimum number. So 80 is not present in your left side. So we will ignore left sub array and we will follow the right sub array to find our 80 number. So now we will change our lower value and higher value because this array we will neglect. So now lower value is mid plus 1. Here mid is 4. So 4 plus 1, it means 5. So now we will consider our lower value is your 5 and higher is as it is. Now second time we will calculate middle value because our lower point is changed. So now lower index is 5 and higher index is 8. So 5 plus 8 divided by 2. That means 6.5. So we will floor the value. So answer is 6. So 6 is your middle value. Here 6 is 65. Now we will compare 65 with 80. So both are not matched and 80 is larger than 65. So now we will neglect this list and we will find new lower value. So now your new lower value is middle plus 1. So middle plus 1, 6 plus 1, it means 7. So here 7 is your lower value. Now we will calculate middle value. So middle value calculation is lower index plus higher index. Here lower index is 7 and higher index is 8. So answer is 7.5. So now we will floor the answer. So answer is 7. Now middle is also 7. So now we will compare our searching element 80 with our middle element 80. So both are equal. That means search result is element at your 7th position. Now in this example we will always change our lower value because search element is always larger than your middle value. So we will change lower value by middle plus 1. I hope you have understood this idea. Now we will change our higher value. So let us see the one example. Here we will search 20 in this array. So we will calculate first middle value. So consider your 0th position is your lower value and your last position as your higher value. So middle value calculation is lower index plus higher index divided by 2. So result is 4th index. So 4th index is your middle value. Now we will compare our middle value with our search value. Search value is 20, middle value is 50. That means both are not equal. And you can also see here search item is less than your middle value. That means right side element is not used because your item is your smaller than your right side part. So we will neglect this array and we will only focus on left side. Now we will change our higher value. So we will neglect this array. So higher value is your middle value minus 1. Here you can see if your x is less than your middle value. That means we will change our higher value to middle minus 1. So in this binary search, we will change our lower value and our higher value and we will always compare our item with our middle value. If our searching item is equal to our middle value, that means search is successfully. But our search data is less than our middle value. That means we will focus only our left part. If our search data is higher than our middle value, that means we will neglect left side and we will always focus on your right side. That means every time searching have 3 conditions. If middle equal to our search item, if middle is less than our search item, or if middle is greater than our search item. So we will check our algorithm for that. Now in binary search we will have 3 values. First is our list, second is your number of element and third is your searching item x. Now we will initialize our lower value, lower as a 0th position, higher as our n minus 1 and we will initialize our flag as a 1. Now step 2, we will repeat this step until our lower is less than equal to high. So we will repeat 3 and 4 step until higher is maximum than your lower value. Now we will calculate middle value. So lower index 0, higher index is n minus 1 divided by 2. So we will calculate mid value. Now we will compare mid with our x. Now comparison have 3 situations. Your x is less than middle value, your x is greater than middle value and your x is equal to your mid value. Now we will see one by one. If your x is less than mid value, that means we will change our higher point because middle value is smaller than your x value. So your higher position is your middle minus 1. That means we will only check our left side subarray. But next is if your x is greater than list of mid value. That means your searching item is not in left side. It is on your mid into right side. That means we will change our lower value. So lower value is mid plus 1. If both are not, then your data is equal to your mid value. So in that situation, we will say that search is successfully and your item is your mid plus 1. And we will set flag as a 0. Now we want to use location. So we will use mid plus 1 because arrays start with 0 index. Now step 5, if flag equal to 1, that means item not found. So at that situation, we will say that search is unsuccessfully and exit. I hope you have to understand binary search. Thank you everyone. Like my session, share my session with your friend and don't forget to subscribe my session. Thank you.